Hello, YouTubers. Steven's Kitchen Counter again. Okay, new idea. 3D print. Any of you that's got a 3D printer can do this. Any of you don't, I am so sorry. I basically bought a 3D printer to come up with my own battery holders. As you can see, this one's got 6 slots in it. And also there is, yeah, you can see it, a little bitty lip right there. Now, that lip is to actually keep the outer edge away from the positive. So when you run the band down, you have to actually push the banding down. Now, how to hook these up, find one that's been done. Aha. Now this is an earlier revision print of this, but still same concept. Yes, it does not have the lip. Run all your leads together. Leave a tab on the outside because you're going to have it. You can either leave a tab on here, or if you do this, you can take another one of these that's like this, and no tab on the opposite end, and extend it out. Wait, actually, tab here and here, fit the pack together, and then you've got parallel. Or you can bend the tabs up and good example how they're being tied together. I've got a hole here, 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 and here, and then a piece that sticks out right there and there, and they're basically just friction fit. That's an earlier revision. I am not too sure that's gonna, yeah, I don't think that's gonna fit together, because that's a way early revision. But anyway, they snap fit. Perfect example is this. They just snap, friction. And, you know, it's not a super duper amount of friction. It's kind of like just snap, and that's it. But these are working out pretty good. And the idea of the concept of these is, let me go get the other battery I do have finished. This is 4S. Yes, it is a little on the long side, but it's 12P. So you got 4S, 12P, and look how clean this is. BMS, positive lead, and then the ground lead, and then your wires that go to your BMS itself. There's only 3 for this. And that's all it needs, because the positive is actually red at the positive lead for this BMS, and then the ground is actually red from the ground itself, and then you've got 3 other wires to contact. With the offset that these have right here, if you do the tabs, you got clearance, which is good. That is 10 gauge wire. Right there. You can hold these together by threaded rod. That makes them more rigid. I was trying to work out to start with something that I could like snap fit from one side to the other, but the thing about it, when you're going from one side to the other, you literally, with that lip, you literally have to flip the part. Now, I did not want to get into having to print a positive and ground side. That's too much. I wanted something universal, and that's what I did. So the way to mount these together would actually be threaded rod, and also there is a end cap to protect the end. This has worked out fine. My first revision of this was less than desirable, believe me, because I tried to do solderless, but the batteries didn't get compressed together right. But when you solder all your ends together and then tie them together, there's no way you can go wrong, because the batteries, once they're done, they get compressed together. So that's like taking a regular battery and putting it positive to ground and compressing it, so it's going to connect. That's all I thought I'd throw out there. Yeah, that's it. And I've got all the battery packs that I built for my home power. I'm testing all of them, make sure they're running okay in balance, and they are. I neglected to fully charge a couple of them and put them in service and let them charge that way. I found out, don't do that. Charge them full, drain them down to where you need the voltage, and then put them in service. So, lesson learned there. And as far as my little 20 amp charger goes, I've had another one in service now for about 3 months, with a fan. At best, you're going to get 23 amp out of those. That's it. That's a safe amount. Anything over that, you're looking at melting the insulator and shorting out the MOSFET, because they just get way too hot. I guess I could poke that out there and let you guys see it. Alright, here it is, with the fan. Can't really depend on hot glue to hold, but anyway. The biggest thing is the MOSFETs get incredibly hot, and so does the inductor. That's the biggest struggle that I've had. Now, thermal pad, the circuit board actually gets really, really hot because of the inductor itself. So I ran thermal pad, and it looks like you might be able to see a little tad bit of blue in there. Turn it over, might be a little more. Yeah, right there. Thermal padding underneath the circuit board going to the heatsink. And then screw down the MOSFET to this heatsink. Like I said, you can't ever depend on hot glue to hold your fans. And then to further dissipate more heat off the MOSFETs, I put a little copper shim on top of the MOSFETs too. This is a voltage regulator for the fan, because I've got 18 volts going in this to charge to 15.7 volts on these batteries. Yes, I lose capacity, but these batteries will last longer if I do not fully charge them. And I only drain them down to 12 volts. Matter of fact, I think 11.9 volts. So that's that's not full using all the capacity of the cells, which is fine. And for charging, on low sun days, batteries drain down to 11.9 volts. I've got a low voltage detector that kicks on and activates the charge itself. So, completely automatic. I don't have to mess with it. Just check on it every once in a while and that's it. But 3 months running now. The only thing about the outputs, as you can see, that plastic will melt. But it is holding up other than that. This is I think 14 gauge wire. And that's really about all that these things can take in too, is 14 gauge. Oh boy, that wire is. Oh yeah, this is the first time I really dug into it and checked it. I'm gonna have to do some changing. Guess I'll be taking this and putting it straight in the circuit board and removing that. And this wire is not thick enough to handle the 23 amp that's going through it, so I'm gonna have to change it to a better wire. Definitely. Maybe pre-10 14 gauge, because this is like, I don't know, it might be 16. But that has gotten so hot that the plastic has melted off. I've got some high temperature stuff sitting over there on my counter where I do all my work at. But anyway, the way this has worked out has been okay. And just keep in mind, if you do use these, make sure you give it plenty of heat sink and also do a cooling fan, and do not go over 23 amp. That is the most it's going to be dependable at. If you're going stock, you're going to have to keep the output below 12. No more than 12. You might be able to get away with 15 over a short period, like an hour, maybe 2 or 3. But the most stable is 12. That's about all I can say on these. But anyway, I am not registered with Thingiverse. But one other thing I am trying to work on too is a slot to go through the side. My stupid printer will not print something that is really thin. So yeah, that's something I'm going to have to work on, because I would like to have a slot going through that, slide the banding through, and then I'm going to have to buy a welder. I can use a soldering iron, but I've got 180 pouch cells, DATLs. 180 of these I cannot use because they won't solder. What a waste. Yep. Anyway, people, if you'd like for me to get registered on an STL because you have a 3D printer, let me know. I mean, Thingiverse. I can upload the STL and then let you guys know later. It's up to you. If you want to print these, then you're welcome to it. But I'm not going to bother to get registered with Thingiverse unless somebody actually wants to do these. Because not everybody has a 3D printer, and I get that. That's it. Alright, have a good one. Hope you guys thought this was rather informational, and you actually like this battery setup. Catch you later.